So chapter 7 is about roots, radicals, and root functions. Section 7.1 is about simplifying rational expressions and what their graphs look like. So we previously looked at exponents, which can be used to square a number. So my base was 3. I take that to the exponent 2, 3 squared, so what we say, and that would give us 9. Now we're going to study square roots and other roots. And what those do is they take us from the root of a number back to the number itself. So for example, the square root of 9 is 3. We could also take cube roots because 2 cubed is 8. The cube root of 8 is 2. And we'll talk about that more on the next slide. So given the nth root of a is b, that means that b to the nth power is a, where a and b are of the same sign. This natural number, n, is called our index, the index of our root. The index for square roots is 2, and it's usually omitted. Just like we don't write leading exponents of 1, we just assume that, we just know that if I write this radical symbol, that radical symbol is the square root of index 2. But you don't have to write the index. So for example, the square root of 6 is 6 because 6 squared is 36. That's what it means with a and b being both the same sign. The cube root of 27 is 3 because 3 cubed is 27. And the cube root of negative 27 is negative 3. And that's because negative 3 cubed is a negative 27. So let's simplify the following. You can use a calculator for this, but it's nice to know some of the main ones right off the top of your head. The square root of 64 is 8. The cube root of 64 is 4, because 4 cubed is 64. The cube root of 125 is 5. The fourth root of 16 is 2. And when it comes to taking the square root or the cube root or the nth root of a fraction, we want to distribute that cube root. So this becomes the cube root of 8 over the cube root of 27, which gives us 2/3. So there are some different cases of nth roots. So if n is even and a is positive or 0, then the nth root of a is the principal nth root of a, right? Because remember, I could take negative 10 squared and that'd give me 100. Or I could take a positive 10 squared and that would give me 100. But when I take the square root of 100, I want 10 because I want the principal nth root. By principal, that means positive. If I want the negative root, we're going to put a negative symbol in front. So if I want the negative square root of 100, that tells me I would take negative 10. We want the negative nth root of a. If n is even and a is negative, then the nth root of a is not a real number. It's a complex number, and we're going to talk about those more in section 7.7, but for now we just say not real, or D&E, which stands for does not exist. Case 3 is if n is odd, then there's exactly one real nth root of a written the nth root of a. So for example, I already said the square root of 100 is 10. You can tell my creativity level is really high. The negative square root of 100 is negative 10. The fourth root of 81 is 3. The negative fourth root of 81 is negative 3, and that's because 3 to the fourth is 81. Friendly reminder. But if I want to take the fourth root, which is even, of negative 81, that's going to be does not exist because I cannot take, this is case 1, sorry, this is case 2. I cannot take an even root of a negative number. But the cube root of negative 8 is negative 2, and the cube root of 2 is 2. We can also think of the principal square root in terms of absolute value. So if I have the square root of 7 squared, that's just going to be the absolute value of 7, which is 7. If I have the square root of x squared, that's going to give me the absolute value of x, regardless of whether x is positive or negative. And if I have the square root of a negative 7 squared, we could take negative 7, the absolute value of that, and I would get a positive 7. So if n is a positive even integer, then the nth root of a is the absolute value of a, and if n is an odd positive integer, then the nth root of a to the n is a, just a itself. We don't have to take the absolute value as long as our index is odd. So let's work through a few examples. So my index is even, so I'm going to take the absolute value of 3, which is 3. In this case, my index is odd, so that's going to give me negative 4. We don't have to take the absolute value. Again, I have the negative, so that negative comes with me. This here is an even number, so this is going to have to take its absolute value. So I have negative 9. Here I have the square root of n to the 4th. Well, that's going to be negative, because I take this negative with me, m squared. We're going to leave that absolute value for m squared. Or we could simplify it, because remember that any number squared is positive, so that could be negative m squared. Next, if I have the cube root of a to the 12th, I'm thinking to myself, okay, what do I multiply by itself 3 times to get a to the 12th? Or you could take 12 divided by 3, which is a to the 4th. And it's an odd root, so I don't take the absolute value. Next, I have the 4th root of x to the 12th. That's going to mean the absolute value of x cubed, because 12 divided by 4 is 3. I'm going to take the absolute value. And I'm going to leave the bars here because since if x was negative, then x cubed would be negative, and if x was positive, x cubed would be positive because it's a cube.